we are given this question, 1 positive 2 times e raised to the power x over y times dx positive 2 times e raised to the power x over y times y 1 negative x over y times dy. Now you have to make a very important note here. You see the exponent's value x divided by y, x divided by y. So because of this, we would be making the substitution for x actually. So that would be, instead of taking y is equal to vx, we would be taking x to be as vy. So this is very important note that you have to take into consideration. So for this to happen, we need to write the expression as dx over dy. So for that, I would retain this quantity as it is, 1 positive 2 times e raised to the power x over y times dx, and then move this quantity to the right side. So that is going to be negative 2 times e raised to the power x over y times 1 negative x over y times dy. So bring dx, I would say bring the dy down to dx. So that's going to be dx over dy is equal to negative 2 times e raised to the power x over y times 1 negative x over y. I'm going to write it as x over y negative 1. So that means this would become a positive sign. Okay. So now this has to be divided by this quantity, 1 positive 2 times e raised to the power x over y. So this is what you have got. Now using the substitution which I mentioned, taking x to be as vy and then differentiating with reference to y, this is going to be dx over dy is equal to, now y is the independent variable, so it's going to be v times differential of y is going to be 1 positive y times differentiating it with reference to y, so it's going to be dv over dy. So using this in 1, okay, therefore 1 will now be rewritten as, so in place of dx over dy, I would be substituting v positive y times dv over dy is equal to 2 times e raised to the power, in place of x over y, so x over y would now become v, so this would now become v times, this would now become v x over y negative 1 times 1 positive 2 times e raised to the power v. So this is what we have got. Okay, so now what we will do is we will move this v to the other side. So that would mean we would now have y times dv over dy is equal to 2 times e raised to the power v times v negative 1 divided by 1 positive 2 times e raised to the power v negative v. Okay, so taking the LCM as 1 positive 2 times ev, we would now have 2 times ev of v negative 1 negative v of 1 positive 2 times ev. So this is what we have got. So this is equal to 2 times v times e raised to the power v negative 2 times e raised to the power v negative 2 times e raised to the power v divided by 1 positive 2 times e raised to the power v. Now positive, can you cancel anything? So if we were to remove the parenthesis and rewrite, we would get 2 times v e raised to the power v negative 2 times e raised to the power v negative 2 times e raised to the power v times v divided by the denominator 1 positive 2 times ev. Now clearly if you can see here, 2 times v ev and negative 2 times ev can be cancelled. Okay, these two terms can be cancelled. So this is going to be negative 2 times e raised to the power v negative v divided by 1 positive 2 times e raised to the power v. I can rewrite it by taking the negative sign out. So this would give me v positive 2 times e raised to the power v divided by 1 positive 2 times e raised to the power v. On the left side, I've got y times dv over dy. So I can rewrite this by interchanging, by using variable separable technique in the following way. So this is going to be 1 positive 2 times ev. Move this up to the left, bring this down, so this is going to be v positive 2 times ev, and move dy to the right. Of course there's a negative sign there, bring the y down. So this is what you would be having. Now integrating both sides, you can write that statement, integrating both sides, we get, so what we would get, of course there is a dv there, so place the dv there. Now to make the substitution on the left, if I were to let v positive 2 times ev to be as some t, and I differentiate, I get 1 positive 2 times e raised to the power v, okay, times dv is equal to dt. This is what I get. So if I were to substitute, so let me show you here. So therefore integral 1 positive 2 times ev times dv divided by v positive 2 times ev. When I make this substitution, this will become, in place of 1 positive 2 times e raised to the power v times dv, I will be using dt divided by, in place of the denominator v positive 2 times e raised to the power v, I would be using t. So this is going to give me ln of t, which can be rewritten as ln of v positive 2 times ev. Of course I have a constant c, you can place a constant c, and using this information over here, I would get ln of v positive 2 times ev with the modulus sign. Now I don't have to place the arbitrary constant on the left side, I would place the arbitrary constant on the right side. So this is followed by negative ln y, positive ln c. Okay, now I already have a negative sign. Now what I can do is I can move this negative ln y to the left. That would give me ln of v positive 2 times e v with a modulus sign, positive ln y is equal to ln c. Now this is ln a positive ln b, this is going to be ln of ab. Now using this formula, I can rewrite this as ln of y times, with the modulus sign, v positive 2 times ev is equal to ln c. Now we know that we started off by taking x to be equal to v times y, so therefore v will be equal to x over y. So I would be using that substitution over here. So this is going to be ln of y times, in place of v is going to be x over y positive 2 times e raised to the power, in place of v is going to be x over y with a modulus sign is equal to ln c. Now this can be further rewritten by removing the modulus and the logarithm. We can rewrite this as y, in fact taking y to be the LCM, this is going to be x positive y times, of course there's a constant 2 there, e raised to the power x over y, okay, times y is equal to c. Of course you can cancel the y's in the denominator. You see there is a y there, you can cancel them out, and that would give you 2 times y times e raised to the power x over y positive x is equal to constant c. So this is what you are getting, and this is the final solution to the given question.